welcome back to my YouTube channel. How are you all? I hope you all are fine and safe at home. So today we are going to discuss permutation when all the objects are not distinct, right? So in the previous lectures we have discussed permutation when all objects are distinct. Distinct means different, when all the objects are different. So today we are going to discuss when all objects are not different, which means some object will be same kind, right? So today's topic is permutation. Permutation when all objects are not distinct, right? So our third theorem is theorem number third, that is the number of permutation of an object where P are of same kind of object and rest are all different, which is equal to n factorial upon p factorial. So this is our third theorem, that is the permutation of an object where p are same kind of object and rest are all different, that is equal to n factorial. N factorial means total number of arrangement, right? So in numerator n factorial will come. N factorial means the permutation of number of object, total number of object means arrangement of total number of object upon in denominator p are of same kind, means in denominator those elements, those objects will come which are of same kind. So this is our third theorem. So permutation of an object where p are of same kind of object and rest are all different. So in denominator only we can write those elements, those objects which are of a same kind, right? So this is our third theorem. In first and second theorem we have discussed permutation of an different object where are taking at a time, all taking at a time, just like this. The permutation of n, but n are different object, right? So n are different object taking r at a time. But in this third theorem, which talking about permutation when all objects are not distinct, means when all objects are not different, sum of elements would be same kind, right? So this is our third theorem. So let's understand by example. For example, root. To find the total number of permutation. So here, how many letters are there? There are 1, 2, 3, 4 letters total. How many letters are there? There are 4 letters in which O appears 2 times, right? In which O appears 2 times, right? So the required permutation, total number of arrangement, or we can say the required permutation will be equal to, in numerator always total number of letters, right? 1, 2, 3, 4. 4 factorial upon, and in denominator how many elements are repeated? There are 2 elements which are repeated. So upon 2 factorial. So 4 factorial into 3 into 2 factorial. 4 3 the 12. right? This is our answer, or this is our third theorem, which talk about when all the objects are not distinct, which is equal to total number of elements, right? Total number of letters, or we can say total number of objects which we will arrange upon the number of objects which are of same kind. In denominator, we will only write those letters which are repeated, right? Which are of same kind, right? So this is our third theorem. Similarly, the fourth theorem is theorem number 4. So the permutation of an object where P1 are of same kind, right? P2 are of second same kind. Similarly, P3 are of third same kind, so on. Pk are of kth same time, and rest are of different elements, different object, and if any rest are of different elements, or we can say letter या object, so that is equal to n factorial upon P1 into P2, so on Pk. That is our fourth theorem, which talk about the permutation of an object where P1 are of first same kind elements, P2 are of second same kind elements, so on Pk are of kth same time elements, and rest are of different object. So which is equal to n factorial, that is total number of letters, total number of arrangement which we will do upon P1 into P2, that though these are repeated elements, right? So this is our fourth theorem. So let's understand this theorem by example. For example, to find the total number of permutation of letter of word Allahabad. Allahabad. So here find the total number of arrangement, or we can say total number of permutation of a letter of word Allahabad. Right? In Allahabad, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 letters, out of which A comes in 1, 2, 3, 4. Right? A comes in 4 times. Similarly, L comes in 2 times. Right? So A 1, 2, 3, 4. Right? L 1, 2, 2 times. And rest all elements are different. Right? So in Allahabad, there are 9 letters, out of which A appears 4 times. Right? And L appears 2 times. And I think the rest letters are different, right? So therefore the required permutation, yeah, we can say required total number of arrangement. How many total letters are there? 9 letters, and upon denominator those elements, those letters will come that are repeated. So like 4 factorial into 2 factorial, right? So 9 into 8 into 7 into 6 into 5 into 4 factorial. 4 factorial into 2 into 1. 2 for the 8. Multiply then 9 into 4 into 7 into 6 into 5. Right? You can multiply these 9 into 4 into 7 into 6 into 5 and answer will come. So students, always keep in mind that in numerator total number of letters will come, that is n factorial, and in denominator repeated element will be right here, right? So this is our fourth theorem. Our next example is, in how many ways can 4 red, 3 yellow and 2 green discs be arranged in a row if the discs of the same color are indistinguishable? Right? So here 4 red, 3 yellow and 3 green discs we will arrange. Right? Therefore, the total number of discs, that is 4 red, 3 yellow and 2 green. That is 9 number of discs which we have to arrange, right? So total number of discs are here. So there are 9 discs, out of which, so there are 9 discs out of 4 red are of same kind and 3 yellow are of second same kind and 2 green are of third same kind, right? So required number of arrangement will be equal to required number of arrangement, which is equal to total number of arrangement like n factorial upon 4 factorial which are repeated, right? 3 factorial and 2 factorial, right? In the next step, you can solve 9 into 8 into 7 into 6 into 5 into 4 factorial upon 4 factorial, 3 into 2 into 1, 2 into 1. Cut 4 factorial, 3 3 the 9, 2 4 the 8, 2 to the 4. So you can multiply these, then answer will come. So in this question, in how many ways can 4 red, 3 yellow and 2 green discs can be arranged? So total number of discs are here, that is 4 plus 3 plus 2, that is 9 total number of discs which we have to be arranged. So in out of 9 discs, 4 red discs are available, 3 yellow and 2 discs, right? So total number of permutation which is equal to n factorial upon 4 factorial into 3 factorial into 2 factorial, then answer will come, right? So next example is, find the number of arrangement of the letter of the word independence. First condition is, do the word start with P, do all the vowels occur together, do all the vowels do not occur together. This is one of the most important question that is we are going to discuss. So in independence, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in independence, there are 12 letters, out of which and 1, 2, 3 and comes in 3 times, out of which n appears 3 times, right? and 2. D appears 2 times. And what about E? E comes in 4 times, and rest are all different. So first step is to write the repeated letters. In this word independence, there are 12 letters, out of which N appears 3 times, D appears 2 times, and E comes in 4 times, and rest are all of different. So therefore the required number of arrangement is equal to, how many letters are there? There are 12 letters which we have to be arranged upon, write down repeated element, that is out of which N appears 3 times, that is 3 factorial into D appears 2 times, only write down here only repeated element, right? Comes in, E comes in 4 factorial, right? So calculate this like this: 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial, and 4 factorial 3 into 2 into 1, 2 into 1, right? So answer 166,320. This is the answer. The required number of arrangement is equal to 166,320, right? So now first discuss first condition, that is, do the word start with P. To find the number of arrangement when the word start with P, right? So this answer we'll write here. So first condition is, do the word start with P. Means find the total number of arrangement, but condition is the first word first letter start with P, like this, right? The remaining, how many elements are there? There are 12 elements, 12 letters, right? Out of which N comes in 3 times, E comes in 4 times, and D comes in 2 times. You have to be remember this, right? The first condition is, do the word start with P. So how many total letters are there? There are, you can write, there are 12 letters. What first letter is fixed right now? First letter is fixed. So how many letters are left? Now 11 letters are left, right? So P letter is fixed, right? So the number of arrangement of remaining, no, we will find number of arrangement of remaining 11 letters, right? So in independence there are total 12 letters, but out of which one letter, that is one letter P, is fixed. So 12 minus 1, that is 11. So now we have to find the number of arrangement of remaining 11 letters. So 11 letters, right? Because one letter, that is P, is fixed. Because the letter start with P, so P is fixed. So we don't have to arrange this. This is fixed, right? So we will arrange now 11 remaining letters. So 11 factorial upon, similarly 3 factorial into 4 factorial into 2 factorial. So I think you can easily calculate this. The answer will be equal to, right? This is the answer. First start with P, right? So next condition is, do all the vowels occur together? Second condition is, do all the vowels occur together? Second condition is, do all the vowels occur together. So in how many vowels are there? So there are I repeated first time, I and E comes in 4 times. So there are 5 vowels, right? So in this word there are 5 words, I, E, right? So there are 12 letters. Out of 12 letters, 5 letters are vowel. So remaining letters are consonant. So how many remaining letters are there? There are 7 remaining letters. 7 plus 5, that is 12 letters, right? So there are 7 consonant and 5 vowels. Now the required number of arrangement is equal to, let's take these 5 letters as a one letter. For example, this is only a one letter. For example, X. 7 X. So how many total letters are there? 7 plus 8. Now we have to arrange 8, total number of 8 letters. So 8 factorial 1. 3 factorial into 2 factorial, right? We have take E 8 factorial upon 3 factorial into 2 factorial, right? But we can also multiply like this, multiply. Now vowel can also be arranged. They can be arranged, right? I comes in first position, E comes in first position, I may be coming in the middle, right? So they will also be arranged. So how can they arrange? 1, 2, 3, 4, 5 factorial. Out of 5 factorial, 4 E are repeated. 4 factorial. Right? This you can calculate this. I will only write the answer. 16,800. Right? So 16,800 when all vowels are occur together. Right? Next condition is, when all vowels are not together. Third condition is, do all the vowels do not occur together. So the required number of arrangement when all vowels do not occur together, which is equal to total number of arrangement, right? Total number of arrangement minus total number of arrangement when all vowels occur together. Then we will get all vowels which do not occur together. So total number of arrangement 1663200, and all vowels do occur together 16,800, and you will get the final answer. So required number of arrangement is equal to total of number of arrangement minus vowels occur together. Then we will get vowels which do not occur together. So this is our third condition. So fourth condition is, do the word begin with I and with P. Right? So in Allahabad, in Independence, there are 12 letters. In Independence, for do the words begin with I and with P. So Independence start with I and with P. Total number of arrangement here are total number of letters 12, out of which out of 12 letters 2 letters are fixed. So how many letters are remain? That is 10 letters. The required number of arrangement that is 10 factorial upon E comes in 4 times, 4 into D comes in 2 times and N comes in 3 times. That is 10 factorial upon 4 factorial into 2 factorial into 3 factorial. You can calculate and find the answer. Right? So this is all about theorem 3rd and 4th, means permutation when all objects are not distinct. Right? So this is all about permutations. Right? So in the next lecture we will discuss exercise. Right? And thank you so much students, and for more videos please like, comment and subscribe my YouTube channel.